Hello and welcome to another video on indices, and in this video we're going to look at negative indices. So what happens when our power that we're raising our number to is a negative number. Now hopefully you will be able to evaluate these ones in black. So 2 to the power 4, we know that means 2 multiplied by itself 4 times. So 2 times 2 times 2 times 2, which is 16. 2 cubed, well that's going to be 2 times 2 times 2, which is 8. 2 squared, well, that is 4. 2 to the power 1 is 2. And in last week's video, I showed you that 2 to the power 0, and in fact anything to the power 0, is 1. Now, I want you to think about what 2 to the power minus 1 would be. And my clue is to look at the pattern that's happening each time. As we go down a power, what's happening to our answer each time? Now, let's have a look. So, what is happening each time? Well, as we go from 2 to the power 4 to 2 to the power 3, so as we're shifting down one power, we are halving our number, or you could think about it as we are dividing by 2. So each time we're going down, we are dividing by 2. So, go from 2 to the power 1 to 2 to the power 0. Again, we're going to divide by 2, which is why I said that anything to the power 0 is 1. Now, if we just repeat the pattern, we're shifting our power down by 1. So if we repeat the same pattern, if we divide by 2 again, well, what does that give us? 1 divided by 2 is 0.5, or if we leave it as a fraction, we could say it is 1/2. So 2 to the power negative 1 is exactly the same as a half. Now let's keep going. What would 2 to the power minus 2 be? Well, we just need to do the same operation. So again, we're going down a power, so we're going to divide by 2 again. So a half divided by 2, the think about it is if you've got 1/2 of something and you cut it into a half, then you'll have a quarter. So you would have 1/4 left. And let's keep going. Let's do this a few more times. So let's do 2 to the power minus 3 and 2 to the power minus 4. So first of all, 2 to the power minus 3. Well, we're going to divide by a half again. Oh, sorry, not divide by a half. Divide by 2 again, or multiply by a half. So a quarter times a half. Well, that is 1/8. And finally, do the same thing. We're going to divide by 2 again. So half of 1/8 is 1/16. And hopefully you can spot some symmetry going on here. So these numbers will get the actual numbers are getting smaller and smaller and smaller until we get to 1. But then if we look at the denominators are getting bigger and bigger and bigger, and in fact the denominators are exactly the same numbers as these numbers here. So you notice how 2 to the power negative 4 is 1/16, and 2 to the power positive 4 is just 16. And that would work for all of the numbers. So 2 to the power 3 is 8. So 2 to the power negative 3 is 1/8. So for example, if we had 2 to the power 5, well, I know that 2 to the power 5 is 32, because it's just 2 times 16. Then 2 to the power negative 5, if we follow the same pattern, it's going to be 1/32. And that would make sense, because if we followed on this pattern here, 1/16 divided by 2 does give us 1/32. So let's just have a look at these indices here. So what is 3 to the power negative 2? Well, if we think about what 3 to the power positive 2 is, we know that 3 squared, well that's 9. So if 3 to the power positive 2 is 9, 3 to the power negative 2 is 1/9. It's always that same pattern. Likewise, let's do 7 to the power negative 2. Well, I know that 7 to the power 2 is 49, because it's 7 times 7. And 7 to the power negative 2 will be 1/49. And finally, 10 to the power negative 3. Well, I know that 10 to the power 3, that's 10 times 10 times 10, that is 1000. So 10 to the power negative 3 is 1/1000. Now hopefully you can spot the relationship between the positive and the negative powers. So when we raise something to a positive power, we just get the answer. Then when we change the power to a negative, it's exactly the same answer, but we always put 1 over that answer. So what I'm just saying here is that whenever we raise something to a negative power, that's always 1 over that same number raised to the positive power. Okay, so it's over to you now. What I'd like you to do is pause the video and see if you can evaluate these 7 questions here. And by evaluate, I mean just calculate the value of. Okay, so number 1, 5 to the power negative 2. Well, we know that's going to be the same as 5 squared, but it's 1 over. So it's going to be 1 over 5 squared. 5 squared is 25, so our answer is 1 over 25. Okay, if we look at question 2, 9 to the power negative 2, well, that's going to be the same as 1 over 9 squared. So 1 over 9 squared. And 9 squared is 81, so it's 1 over 81. Okay, question 3, 3 to the power negative 3. Well, that's going to be the same as 1 over 3 to the power positive 3, which is 3 cubed, and 3 cubed is 27, so it's 1 over 27. Question 4, so this is going to be 1 over 4 to the power positive 1, and 4 to the power 1 is just 4, so it's just 1/4. So our answer for that one is just 1/4. Question 5, that's going to be 1 over 1 to the power positive 5. Well, 1 to the power positive 5, that's just 1 times 1 times 1 times 1 times 1, which is just still 1. So it's 1 over 1, or I could just write 1. So our answer for that one is just 1. Question 6 is going to be 1 over 20 squared, and 20 squared is 400. That's going to be 1 over 400. And this last one, question 7, it looks a bit trickier than before, but if we just apply the same technique, so whenever we raise something to a negative power, it's always 1 over the same number raised to the positive power. So it's 1 over a half squared. Now, what is a half squared? Well, a half squared is a half times a half, and a half times a half is a quarter. So it's 1 over a quarter. Or you could think about this as 1 divided by a quarter. So how many times does a quarter go into 1? Because this here, this is the same. I could write it as 1 divided by a quarter. So if I'm taking something and I'm splitting up into quarters, how many of those quarters do I have? Well, I've got 4 of them. So for this, my answer is just 4. So hopefully you found this video useful and enjoyable at the same time. And in the next video, we're going to continue our theme of indices, but instead of looking at negative powers, we're going to look at fractional powers. See you then.